the cumulative distribution function of a PDF, which is continuous to what you are going to see in this lesson. So, the CDF of a continuous non variable x with a PDF f of x is given by capital F of x, where this capital F of x is cumulative. As we saw in the script, even a capital F of x is going to be x less or equal to values below a certain value from one point to another. If you have x of I is given by this. Now it means that if your interval was from A to B, x of I will interpret from the lower interval up and reach that x there. F of x dx. That's how we get our PDF. Let us see what happens. If m is the median, then the median, substituting the median in capital F of x, you get 0.5. And also here we note that when you differentiate capital F of x, you'll be getting our PDF back, the coordinated distribution function back. So whenever you're doing this, to get this back, you differentiate the PDF. And also, always our f of x is between 0 and 1. And if f of x is 0, it means that even also capital F of x is a 0. Let us see now. If you similarly, if you have the median is 0.5, if you have the first quartile is 1 over 4, if you have the third quartile is 3 over 4, if you have the nth decile is the n that decile over 10. In capital F of x, so to get the median or quartile, you just substitute into the capital F of x. We shall be getting that what we are looking for over 100 if it's a percentile. So let us see this example here. A continuous non variable x has a probability distribution given by this. Find the cumulative distribution function. So you see that now from there, the function we are having our f of x is x over 2. And so we are on the interval of this x less or 2. If we use double variables, if I want now to change this one to t, this one where there is x I'm putting t to be t over 2. Now, we check on the interval. So, we need now to check where x is below 0. So, my capital F of x now for this one here. So, when x is below 0, when x is below 0, we say this means that anything which is not in this range is 0. It means that when x is below 0, we say it is below 0. This function, this PDF, was defined before from 0 up to 2. So below 0 we are in the negative. It means that 0 elsewhere. It means that now our f of x is 0 below this first interval. It means that now our f of x will be at 0. And if our f of x is 0, it means that even our capital F of x is also 0. So as simple as that. So below 0, our capital F of x is 0. Now, from there we move in the next interval. We substitute capital F of 0 so that we can move with it. So now we come to that interval there. In simple terms, here what we are doing, we are getting for below 0. We are getting our x here. So this is the probability when x is less or equal to 0. And so this is the integral from below 0 because this is the first interval is still from 0 to 0 of our f of x dx, which will be 0. So that's what we mean here, below 0. So now, now we are going to carry this value of x. So when you substitute this value of x at the upper here into this, so that our f of 0 will be 0. So now we carry on this value to the next interval, which will be now for 0 less x less 22. Now we are in this interval here. So now our actual f of x now here is going to be the 0 from the first. From here we got the 0. So the 0 you are going to mean when you are substituting in the 0 in this function we got is 0, then plus. Now from this 0 now to the x in this function here. Then my f now will change, our capital F of x will change to f of t numbers. We just send the command so that you don't get confused. In simple terms, we are getting from 0 to x. But if you're okay with it, you can make this f of x and this one the x. But to avoid confusion, we just send the variables and we use the dummy variable t. So now, when we integrate this, we shall get, when we integrate this now, you can clearly see that my f of x is going to be, now when we integrate this, we have from 0 to x now of our t over 2 dt. And integrate this, you get this squared over 4 from 0 to our x, this x here. So this will be now x squared over 4 when you put in that image. It means that now for the interval of 0 to 2, our f of x is that. So our f of x is x squared over 4. Now we need a value we take on the next interval, which is going to be about 2. So now we substitute this upper limit in this. So our f of 2, this is our f of 2, we are going to get 2 squared over 4, which will be 1. So now we come to the next interval. This was the first, this was the second, then we are coming to the last when x is above 2. When x is above 2, now we carry on this value we got. So means that now capital F of x here will be the value we got after substituting in the limit from the upper limit from this interval, which is 1, so we get 1 now plus. But remember, this PDF was defined for values between 0 and 2. So meaning above 2, our f of x was 0. So above 2, our f of x was 0 according to this. So meaning that now we say if f of x is 0, even our capital F of x is 0. So here, now, so just write is 0. Because on this interval, above 0, we add 1, then plus this 0, because our f of x is going to be 0. And it's that above 2, our capital F of x is still a 1. So from there now, we write our PDF as, our CDF as we had the interval, it was 0, below 0, so it was 0 for x, below 0. Then it went to x squared for this interval, x squared over 4 for the interval. That, for that interval is where. Then we come, it was 1 for x above 2, then 1 for x above 2, and so that will be our capital F of x. Members, I wish you well. There are going to be some examples about this.